Hello, I'm Mark, and welcome to part 2 of my Unreal Engine tutorials on how to build a physics-based movement component for your Unreal Engine games. So in this tutorial, we'll be creating a simple flying cube, as seen here, to test out our movement component's functionality in a standalone gaming environment. So as you can see, we can move forward, we can move backwards, we can talk left, talk right. If I just move forward without any input, the friction of the ground is actually torquing our physics body for us. So I'm just going to have to add some additional torque of my own to try and keep things going a little straight. But we should also be able to move side to side as well. So we'll be able to test across multiple axes using both forces and torques. All right, so I'm just going to go ahead and put this to one side. So as always, I like to start things off with a quick little recap of what we did in part 1. So let's go ahead and just move this off screen real quick. And I'm just going to bring up Visual Studio and move over. So the first thing we did in part 1 was to update our build script. And that was located under physicsmovement.live.build.cs. Well, that's where it's located for me. And what we did was we just added these additional dependencies, the physics core as well as the chaos modules, to our solution. Next, we went ahead and created our deferred forces loader. And so this is a structure that will reside within our physics movement component that will help to store the data, all this force data for us, and then allow us to then apply that force data to a physics body, or when we want to apply that all that information. And then we went ahead and created the physics movement component, and that was derived off the Born movement component. And this is where we can get access to our asynchronous physics tick component function right here, as well as it will give us access to our deferred forces loader, where we will then allow us, and it will also manage all the setup needed to allow us to set up and then move a physics body using any forces that we put in the deferred forces loader. All right, so with that out of the way, I'm just going to go ahead and minimize Visual Studio. So for this tutorial, part 2, we're just going to be working within the editor itself. So for that, and with any movement system, we need some movement inputs. So let's go ahead and get started on that. So I'm just going to come into the content drawer. I'm going to go to content. And then under content, I'm just going to create a new folder. And I'm just going to call this movement. And then under movement, I'm going to create a couple of more folders. The first one is going to be blueprints. And that's where we'll put all of our blueprints. And then the next one is going to be input. And this is where we'll put all of our additional enhanced inputs that we're going to be using. And then under inputs, I'm going to create another folder called actions. And then we'll just go into actions. So for this, we just need 3 enhanced inputs. So to create that, we're just going to right click, go to inputs, and go to input action. And I'm just going to go ahead and give this a name. This is going to be IA throttle. And I'm just going to make underscore X, since I'm going to have one on the X and one on the right. And within here, we're just going to pop this open. And as you can see, this is set to digital build. We just want to reset this to axis 1D. All right, so once that's set up, I'm just going to go ahead and actually I'll just keep this up for now. Actually, no, we'll minimize this. And then let's go back to the content drawer. So I just need 2 more of those. So to do that, I'm just going to go ahead and just duplicate this. So I'm going to make this one throttle Y, and I'm going to duplicate it again. And instead of throttle Y, I'm going to rename this your input, as in your, as in W or UAW. All right, and I'm just going to hit save. Let's just save those inputs. All right, so now that we've got our inputs, we now need a mapping context, an input mapping context. So to do that, I'm just going to come back up to inputs, and I'm just going to right click, go to input, go to input mapping context, and I'm just going to go ahead and abbreviate that. IMC underscore, and I'm going to call this flying cube, since this is going to be used for the flying cube. And let's just go ahead and just save that real quick. I'm going to bring back up the drawer, open it up. All right, so now that we've got our context, let's go ahead and add the actions to it. So I'm going to hit 1. So under the plus, let's go in, I'm going to find my throttle input X. All right, so now let's assign this. So I'm actually going to be using a Microsoft wireless game controller for this, since I think it just works well when dealing with moving objects, around. So to do that, to do the mappings, right, all I have to do is I just with the controller turned on and Unreal Engine, making note that it's there. All I need to do is I just need to click on the little keyboard symbol, and I'm just going to push the left stick up, and and Unreal Engine will automatically detect that and say, okay, map that left stick up to the up axis. And since this is an analog stick, I'm going to add an additional modifier to it, and I'm going to use the dead zone modifier. And so what this does is it makes sure that I have to have at least a little bit of pressing up or down on that stick in order for it to detect that there's actually an input in there. So it's using so anything under 0.2, it will ignore coming from the stick. So this means that I definitely have to start pushing forward for it to be able to notice that. So that's set up. So let's go ahead and add the next mapping, and the next mapping is going to be for I'm going to set this up for my Y throttles, and I'm actually going to put this on the left digital pad instead. So to do that, I'm just going to click, and I'm just going to hit left digital to go left, or the left digital pad's left button to go left, and I'm going to add another one, and I'm going to put it on the right digital pad. And then on the left pad, all I'm going to do is I'm just going to add a modifier, and I'm just going to tell it to say negate. So anytime I press this, instead of giving me a 1, it's going to give me a -1 instead. So this is how I can then determine whether we have a left or a right coming in off the gamepad. All right, and then we have one more, which is going to be our your axis. And for that, I'm actually going to be using the shoulder buttons. So very similar to what we did with the D-pad. I'm going to go and click left to go left. And I'm going to add another one to go right. And then under the left, again, I'm just going to say negate. All right, and that is all, should be all we need to set up our inputs into this input mapping context. All right, so now with that out of the way, let's go ahead and create our flying cube blueprint. So I'm just going to keep this up. Give us a little bit more real estate. So I'm going to come to the content drawer. I'm going to move to the blueprint folder under movement blueprint. So content, movement, blueprint. I'm going to right click, and we're going to create a new blueprint class. And I'm going to create this under the pawn actor. So we'll go ahead and create a pawn class. And I'm going to say BP underscore flying cube. All right, now that that's created, let's go ahead and pop this open. All right, so first off, let's go ahead and set up the cube. So to do that, all I'm going to do is I'm going to come to components on the left side, go to add, and I'm just going to find the cube and click on it, and Unreal Engine is going to create me a static cube, and it's going to place it dead center of the actor. And then next I'm going to go ahead and move this up to make the cube the default scene component. Alright, so now that we've got our cube, we've got our material attached to the cube. So because we want to use the physics system, physics systems only work on physics bodies, so we need to make this a physics body. So to do that, we just need to come down to the cube's physics and turn simulate physics on. And I'm actually going to disable gravity initially for this demo, but we can turn this on a little bit later. So what this will do is it will create a physics body which is just floating in zero gravity for us. And then after that, we can come down to the collisions, and as you can see, by making this a physics body, Unreal Engine's already told it to make it a physics actor, but we could also turn this into a vehicle as well. So we can still change it to be what we need it to be. So I'm just going to set this to vehicle because eventually this cube could end up becoming some kind of a vehicle for us later on. Alright, so everything else can stay the same. Alright, so now that we've set that up, we're going to need some way to follow our actor and see where we're going. So to do that, let's go ahead and add a spring arm. So I'm just going to click spring arm. And I'm going to make its length 600. So I'm changed that from 300 to 600. And I'm going to put a socket offset on the Z axis of 150. 50. There we go. Hit save and compile. And then on the spring arm, let's go ahead and attach a camera. Alright, so now we have the camera that's looking in front, and we have our cube, which is a little bit lower than the camera's position. That'll allow our camera to kind of see what's in front of the cube a bit. And we can keep everything on the camera as default. As far as the spring arm, the camera settings will keep the inherit pitch, yaw, and roll. We don't need to do anything there, and I'm not going to put any camera lag in for this. We'll just keep this thing locked tightly behind the cube. Alright, so now that that's all done, the only other thing we need to add is our physics component. So let's come back up to add, and let's find that. And there it is, physics movement component. So I'm just going to add that there, and that's our component. So I'm just going to hit save and save. And now that is added in with everything else, and there's no configuration that we need to do here right now. So we'll just take it as is. Okay, just cleaning this up a little bit. And there's our debug if we had any debug messages in there. Alright, so that is all set up. So let's go ahead and get this set it up so this cube can start moving. So to do that, we're going to need to set up some. Yeah. So to do this, we're going to need to set up the input mapping context first. And on Unreal Engine 5.5, they have this new event, which is the receive controller change event. So. There it is, receive controller change event. And so what this does is that any time that the controller changes, right, this thing will fire. So, and this is very useful if you're creating games in which you have characters which may be, possessing mounts, like vehicle mounts or creature mounts, right? And you're going to be switching your controller from the character to the mount and back again. So what this does is that, and so whenever that switch happens, this will fire and will allow you to then set up, make sure that your controller has been set up correctly. And so we're going to be setting up the mapping context of this. So it has this is the old controller, this is the new controller. So what we want is the new controller. So we're going to take the new controller and we're going to say cast to the player controller, which is right there. And then off the player controller, we're going to be looking for the enhanced input local player systems. So, and there it is under local player subsystems, enhanced input controller subsystems. And then off this, I'm going to put an isValid. And I'm going to use the isValid macro for this. So I want to make sure that everything here is set up before we do it, before we go ahead and add the mapping context. And then off here, all we're going to do is we're going to say add mapping context. And we'll just connect that on the isValid. And from here, we're going to find our flying cube. We'll keep the priority as 0. And that's all we need to do to set this up. So when we start our game and we start as the cube, this will fire and then this will set up the mapping context for us. All right, next we don't need begin play and we don't need overlap, but we will need event tick. I'm just going to move this up here. So next, let's go ahead and create some variables that we're going to use to help calculate our force accelerations for our cube. So to do that, let's start with the throttle inputs, or the input controls first. So to do that, I'm just going to come under variables, and under variables, I'm going to say, call this one throttle X, well, throttle, go call throttle input X, and we're going to make this a float. And I'm going to just duplicate this for our input Y, and I'm going to duplicate this again for our your input. All right. And then the only other thing that we need is we need to have the state. We need to be able to figure out what state, and from the state of the object, we need to know which direction we're going in, so that when we apply the forces, we apply those forces in the right direction. So to do that, again, we're just going to create another variable, and we're going to call this, I'm going to call this travel direction, and I'm going to set this to a rotator. All right, and right now we can just grab this travel direction. I'm going to say set. So, and I'm going to add this to the onTick event. And here, I'm just going to say get actor rotation. So this will tell us which direction we're traveling in as we're moving our object. All right, so next let's go ahead and hook up our inputs. So to do that, well, we'll find the IA throttle X, and we will go ahead and set that input right there, keeping things real simple. And we'll find our IA throttle input Y, and we will go ahead and put that guy here. And let's go ahead and find our your input as well. AI underscore your input. And let's go ahead and drag this over here and set that. Right, so now we're setting up, so when we create this, we're going to take the inputs and put them into these variables. So now we need to convert these into force accelerations and this into a torque acceleration. So to do that, I'm just going to go ahead and create some functions and then add those into the tick event. So let's go ahead, and I'm going to start off with the add forward vector first. So I'm going to come under functions here. I'm going to say on the left and say add. So we're going to add a new function, and I'm going to call this add forward acceleration. All right, so in order to add a forward acceleration to our physics movement component, all we need to do is we just need to say, let's take the travel direction that we're getting from an updated tick, and we're going to say get forward vector, which is the direction that it's going in, and I'm going to say get the throttle input on X. So this is the input value that we're putting in. And all I'm going to do is I'm just going to multiply this. So we'll get the multiply key. And we'll just drag that in there, drag that in. So first off, we're going to go ahead, get the travel direction, which is the vector multiplied by the input that we're putting in. And then I'm just going to go ahead and do another multiply. And I'm just going to change this to a float. And this is really just the magnitude. And I'm going to put a magnitude of 800 in for now. And that's pretty much all we need to do. So next we'll just go grab our physics movement components. And on there we have our add force. So we're just going to add a simple force to the object, and we're going to put it in there, and I'm going to make it an acceleration change, and that should do it. And then the last thing we want to do, so one other thing, and I'm just going to do this because I want to reset this input, this throttle input, every time we reuse it. So to reset it, all I need to do is take this, and I'm going to hit a set, and it's going to be reset to 0. So I just want to make sure that once we're done with this, we just consume it and reset it back so that it'll take the next input in. All right, so that's forward acceleration. So the next one is going to be our right acceleration. So I'm just going to go ahead and just duplicate this. So because the structure is basically the same, we just need to change the variables. So I'm going to say duplicate. And instead of forward, I'm going to say right. I'm going to take the Y, and so we're going to change this to say get right vector. So we don't want the forward vector here, we want the right vector. And we want the throttle input for Y. I'm just going to grab that, and I'm going to put that there. As you can see, my controller just turned itself off. And then again, we want to make sure that we consume that input. And again, this is acceleration change, so that is turned on. Forces is in the force, even though it's an acceleration. It's going to go in there, and the system will handle that. All right, and then the last thing we're going to do is our torque. So to do that, I'm just going to go ahead and again create a new function, and we're going to say add right torque. And for this, we need to be able to determine an up axis. So I'm going to create a local variable, and I'm going to make this a vector, and I'm going to change its name to up up axis, and I need to just set the up axis to 1 on the Z. So this is just a variable that, and it's a local variable which is going to say this is our up. This is how we're going to define up. So in order to do with a torque, we're going to take the up axis, and we're going to then multiply the up axis by the your input, and then again we're just going to multiply it by give it a magnitude, and I'm just going to go ahead and where is it? Nope, there we are. Float, and I'm going to give this a magnitude of 0.5. That way it's not as quick since it's a digital input. And again, we'll just grab our physics movement and we'll say add torque in radians. I'm going to put that in there, put that there, hook that up. And I'm going to say this is an acceleration change. So again, this is set to true. And then once again, once we're done with this, we'll go ahead and consume the input by setting it to 0. All right, now that that's all done, let's go back to the event graph. We're going to come up to tick, and all we're going to do is we're just going to say on tick, add that, add this, and add this. So what we've done is we're adding these forces on tick into the hopper so that they're ready to be consumed. And then all I'm going to do is I'm going to come up to physics movement and we'll just say apply. Hit save, and that should do it for getting a cube to fly in an environment. All right, so now that we've got this set up, we want to test it. So, and when dealing with something like kind of like these kind of movements, we want to have a very big environment to do that in. So what we're going to do is I'm just going to go into, let's go ahead and create a new map so that we can fly this in a new environment. So I'm just going to go ahead and just take this off screen real quick. So this is kind of a little too small for what we want. So I'm just going to come up to File, go to New Level, and I'm going to take Open World, and I'm going to tell it to create me an open world. All right, so there's our open world map. And then what I'm going to do is I'm just going to hit save, because we probably want to save this. And then under movement, I'm going to create a new folder called map. And we will just save this map here, and I'm just going to call this wide open space, why not? So I'm going to hit save. It's going to go ahead and save it, as well as any other information it needs to save. All right, so now that we've got this, let's go ahead and see if we can get this cube to move. So I'm just going to drag this cube and park it in the game. And as you can see right now, and this is going to be important later on as we start building more and more physics stuff, you can kind of see that the cube is kind of in the ground, halfway in the ground. And that's pretty much because the cube has been placed right in the middle. And that's the center of gravity, and that's the focal point of the cube moving. So when we kind of get in, if you want to start talking, pitching, and yawing, it's going to be doing it around that focal point. And so sometimes, especially if you're using a skeletal mesh which has a root bone, it may put that object higher up, and it may start to look kind of weird, especially if you're using forces. It's probably just because your forces are relative to that 0, 0, 0 of the actor, but your character might be higher. So if you can move the character down, otherwise you'll just have to kind of make sure you're add an offset. And we'll get to that when we get into thruster systems a little bit later. But for now, we're just going to go ahead and see if we can get this cube moving. So I've turned gravity off. We've got this cube. I'm going to give it some space off the deck. Alright, so let's go to details. So the last thing I'm going to do is I'm just going to come under details, and under flying cube, I'm going to say, instead of auto possession player, I'm going to set that from disabled to player 0. And I'm going to hit save. And if we've done everything correctly, I'm going to go ahead and power up my controller again. And I'm going to hit play. And then I'm going to, as you can see, I've got my little man, you know, Quinn's kind of like hanging out there in space. And then I'm going to click. And if we've done everything correctly, we should be able to move our cube using our physics movement components, as you can see right here. There's your X, and as you can see, it's definitely got some stiffness in there. And then that's our your left and your right, throttle left, throttle right on the y-axis, and then there's throttling on the X and throttling on the Y. And it looks like it's all working. Alright, so I'm just going to go ahead and just turn this off. And if we really want to test out the physics part of it, let's go down to the cube, and I'm going to turn gravity back on again. Hit save. Let's just move this back off screen. And we're going to run it again. And as you can see, boom, gravity just took hold of our cube, and it's on the ground now. And as I give it some throttle, it's starting to move, and friction is moving me left. So I'm going to have to put in some right torque, or friction's moving me right, so I'm having to put some left torque in there. So as you can see, the friction of the cube along the ground is actually moving it in unpredictable ways. So I'm going to have to add torque in there. And as you can see, if I take my hand off the controller, the friction is actually stopping the cube from moving. So we now actually have the ability to move a cube using the physics system while letting the physics of the ground and gravity add additional stuff, additional control, constraints on our movement. All right. Okay. So everything looks good there. So that's going to do it for part 2 of the series, which is our flying cube. In part 3, what I'm going to do is we're going to take it up a notch, and we're going to go ahead and networking. So we'll be bringing it back Visual Studio and building all the network, adding all the missing network pieces into our physics movement components. So that we can then go ahead and move across the network. So that will be in part 3. All right, so if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel, and I will see you again in the next video. Cheers. Bye.